Hi, so this is my example I want you to have a go at. A car is travelling at 20 metres per second when someone runs into the road. It takes 0.5 seconds for them to react. They then apply the brakes. The person is 30 metres in front of them. Do they stop in the required distance? So you can either work through it with me, or if you want to have a go yourself, and then till you get the right answer, that's fine. If you're going to do it yourself, structure it this way. You might want to draw a graph, which is actually very helpful, and just work out the area underneath. Quickest way. Or you can do the thinking distance, which is distance velocity times time, and then you can do the braking distance, which is where we use v squared equals u squared plus 2as. I will do the hard way, and then I'll quickly show you the easy way. So number one, okay, so pause now if you're going to do it yourself. If you're going to do it with me, number one, let's write down our values. So a car is travelling at 20 metres per second. So the values we're going to need for this are u, v, a and s. And some t's times. So, actually, I'm not going to do it this way. I'm going to do the thinking distance first, sorry. So thinking distance. So our thinking distance is our speed times our time. So if we go to the question, this is where they're thinking, I'll highlight it in pink. They travel in at 20 metres per second and it takes 0.5 seconds for them to react. So that's as they're thinking. So our speed is 20 and our time is 0.5. And that gives me a thinking distance of 20 times 0.5, which is 10 metres. So that one's really straightforward. Our thinking distance is 10 metres. Now, for the second equation, for the second part, we're going to use this equation. V squared equals u squared plus 2as. This is our braking distance. So for this we need some values. We need what we end up at, what we start at in our velocities, we need our acceleration and we need our displacement. And in fact I've not put one of the values you need in the question, so I'm going to pop it here. The deceleration is equal to, and I've written it down on the page, just give me a second, minus 1.3 metres per second squared. So you actually need that value. So in an exam question it would be given to you. So let's pop our values down here. Let me just zoom out a tiny bit. Okay, so our V is what we end up at. So they then apply the brakes. The person is from 30 metres in front of them. Do they stop in time? So the first thing they're going to do is stop. So that's what we end up at. That's our V. So that's 0 metres per second. Our U is what we started at. So that was 20. Okay, so we use that 20 in both calculations. And we need our deceleration or our acceleration here, which we've got here, which is 1.3 metres per second squared. So minus though, because it's decelerating. And we're going to work out S. So put in the values then, the next stage. So V squared, so we've got 0 squared equals U squared. So we've got 20 squared. Plus, pop it in a bracket, 2 times our deceleration, which is minus 1.3 times S. Then, let's get out all the fiddly maths. We've got 0 squared here, which is 0. We've got 20 squared here, which is 400. Okay, so pop that in there. And then we've got this little bracket thing to sort out. So we've got 2 times 1.3, which is 2.6, but it's negative. You've got a plus and a minus here, so it becomes a minus. So you've got minus 2.6s. Right, so now I need to rearrange it. So I'm going to take, I've got a plus 400 on this side. So I'm going to take it to the other side and it becomes negative. So minus 400. equals minus 2.6s. And I then have a minus 2.6 here, multiplied by s. So I'm going to divide both sides by minus 2.6. So 0 minus 400 divided by minus 2.6 equals minus 2.6 divided by minus 2.6s. And then these cancel. Okay? As you get better at doing this, you can miss out this stage. You can just move your minus 2.6 down here. So I'm now left with an s on this side, and I need to figure this out. So I need to do 0. So on my calculator, look what I'm doing. I'm putting a divide in. And I'm doing, oh, actually, I'm not even going to do that. I'm going to do the top first. So I'm going to do 0 minus 400, which is minus 400. And then I'm going to divide by minus 2.6, which gives me 153.8. I'm just going to round that up to 154. Yeah, so I've written the full value there, and then I'm just going to round it to 154 metres. Okay, so I now have my two values. I've got my thinking distance and I've got my braking distance. So now I need to work out my stopping distance. I don't think this is going to be very good for the person on the road. You might have already spotted this. So my stopping distance equals my thinking distance plus my braking distance. So my stopping distance is 10, but my braking distance is 154 metres. That's because they were going really fast at the start, and because you have to square the speed, it made that number really big. 20 metres per second is pretty fast. So my answer, my stopping distance is 164 metres. So, do they stop in the required time? The answer is no. Sad face. Sorry. That's my fault for using 20 metres per second at the start. I should have thought that maybe it might be a bit longer than 30 metres. But it does go to show that speeding actually has a huge effect on how long it takes you to stop. And the reason for that is you have to square your speed in this calculation. So it can have a massive impact on your stopping distance. Okay, now have a go at the questions. Try the foundation one where we just do this. Okay, and then you can try the higher one as well. Actually, what I'll just show